Welcome to Math with Professor V. This is part of the lecture series Algebra Review for the Calculus Student, and in this video we're going to learn how to simplify complex rational expressions and then look at examples in your calculus class where you're going to need to do exactly that. So first things first, let's get a definition under our belt. A complex rational expression is a rational expression in which the numerator and or denominator themselves contain rational expressions. So basically it's when you have a fraction and then there's another fraction sitting inside the numerator and or the denominator. And there's two methods that are commonly used for simplification of complex rational expressions. Now, either will always work, but sometimes one method is easier than the other, and we'll talk about how to identify which is which. And you should be prepared to use either method. So the first method is you multiply by 1. Basically, this method makes use of a common strategy that we use for fractions all the time, in which we rewrite fractions into a more desirable form by multiplying the fraction by 1. Now, in these problems, what is that 1? Well, it's written using the LCD of all of the minor denominators in the expression. If that went over your head, don't worry, we're going to hop into an example and it'll start coming together. So use method number 1 to simplify. So I want you to look here at this example. What I need to do is identify what the LCD is for all the minor denominators. What are minor denominators? All of the denominators of the rational expressions within the overall rational expression. So what would be the LCD for 9, m squared, 3, and m? Well, the LCD for 3 and 9 is 9, and the LCD for m and m squared is m squared. So LCD for everything is 9m squared. Is that part okay? All right. What we do from here is we actually multiply everything in the fraction, in this rational expression, by 9m squared. 9m squared. And you don't have to do this, but sometimes some of my students get confused and they like to put over 1 just to remind themselves that that 9m squared is in the numerator always when you're distributing it through, okay? So in this next step, I'm going to kind of show you the longer way to do it, and then when you get more comfortable, you can totally feel free to go and cancel in your head. You don't have to do it step by step like this, but let's just break this first one down. In the numerator, we're going to have 9m squared over 9 minus 9m squared over m squared. And then in the denominator, I'm going to have 9m squared over 3 plus 9m squared over m. Are we okay? All right, good. Now cancel, simplify each of those 4 terms. So 9 is gone here. That's just going to be m squared minus, and then m squared cancels here, so that's 9. Now moving to the denominator, these cancel. This is just a 3 down here, so 3m squared plus, good, the m cancels, and that's it, 9m. How are we doing? Once you distribute the LCD and simplify, you shouldn't have a complex expression anymore. It should not be a complex rational expression, which it isn't. However, we always want to make sure it's completely simplified. And in order to do so, I'm going to factor the numerator and denominator because both factor. So m squared minus 9, that's a difference of squares. That's going to factor into m plus 3 times m minus 3. And then in the denominator, I can take out a 3m, and then I have m plus 3 left over. Good? Well, lo and behold, yes, more canceling fun. M plus 3 is gone. So then we're left with our final answer, completely simplified, m minus 3 over 3m. So we're going to revisit this problem once we talk about the second method, but for now, hopefully method number 1 is making sense. And honestly, I'm going to tell you, in most of the calculus problems we encounter, this method is better, okay? All right, let's move our attention to another one. Let's see how you guys are doing. 2x plus 10 over x minus 3 over x squared minus 25 over x squared minus 9. Now, in order to identify the LCD for all the minor denominators, we have to first see where are they. So here's the denominator up top, and here's the denominator in the bottom. And remember, whenever we're trying to find the LCD, everything needs to be completely factored, and x squared minus 9 isn't completely factored. So let's take care of that first. So we have 2x plus 10 over x minus 3 over, this is x squared minus 25 over x plus 3 times x minus 3. So now here are the minor denominators. What's the least common denominator for those two? Good, just x minus 3 times x plus 3. Perfect. So in method 1, what I do is I come through and I multiply both the numerator and denominator by that LCD. So essentially I'm just multiplying by 1, nothing illegal is going on. If you want to remind yourself these are over 1, feel free, okay? And then now I'm just going to go ahead and cancel and write what's left over immediately. So up top, x minus 3 cancels. We have 2x plus 10 times x plus 3 over, and then look, all of this cancels with the entire denominator in the bottom, and we just have x squared minus 25. Again, we're not done. We want to factor completely and see if anything cancels. So I can take a 2 out from the 2x plus 10, and I'm left with x plus 5. I still have that x plus 3. And then x squared minus 25 is a difference of squares. So this is x plus 5 times x minus 5. Ooh, x plus 5 cancels. Fabulous. And then this is 2 times x plus 3 over x minus 5. And that's it. Good. Okay, so this is method 1. Now we're going to look at method 2 and revisit these same problems. So method 2 requires us to rewrite the problem using division. We perform any addition or subtraction necessary sometimes, which this is why I don't like this method as much, to rewrite the expression as one single rational expression divided by another. We then complete the indicated division. So basically what this method has us do is rewrite this overall fraction bar as division. And for this first example, which was our second one earlier, it actually works out nicer. I'll show you why. So we have 2x plus 10 over x minus 3 divided by the denominator. So you rewrite that fraction bar using your division symbol. And then when we're dividing rational expressions or fractions, you could think of it the same way, you change it to multiplication and you flip the second one. So I'm going to write it as times x squared minus 9 over x squared minus 25, like that. Now, it might have been a minute since you've done something like this, so let me remind you, no, you're not going to just start multiplying everything out and having this foiling party. It would be disastrous. You're going to factor and cancel first as much as possible. So 2x plus 10, I could take a 2 out, and I have x plus 5. X minus 3, that's factored. If you want to put parentheses around it, that's a good idea, just to remind you it's taken care of. X squared minus 9, that's x plus 3 times x minus 3. And then x squared minus 25, that's x plus 5 times x minus 5. Good. Now here's my favorite part where you get to throw your cancel party and you just cancel your little heart out. Boom, 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 boom. And then we're done. So here we're left with 2 times x plus 3 over x minus 5. And obviously when you're comfortable with this method, you can be a little more slick. And right away at this step, when you switch it to multiplication by the reciprocal, you can start factoring, okay? You don't have to break it down so much. I'm just doing it so I don't overwhelm you guys right now. All right, good. Let's revisit that very first problem we did and see how this method works for that. So in this case, I'm going to take the entire numerator, 1/9 minus 1 over m squared, and then divide that by the entire denominator. See, this method doesn't work so nicely for this problem because I can't switch it to multiplication and take the reciprocal of this because this is not one rational expression just yet. I have to add these together. And in order to do so, I need a common denominator. And I got to do the same thing here. Okay, so we have a little bit of prep work first. You see the issue? So the common denominator just for these two is 9m squared. So I'm going to multiply this guy by m squared, 9, 9. So we're going to have now m squared minus 9 over 9m squared divided by, and then the common denominator for the next two is just 3m. So I'm going to multiply by 3 and m respectively. And then this is going to become m plus 3 over 3m. Now I'm ready to go ahead, change it to multiplication, flip the second expression. So we've got m squared minus 9 over 9m squared times 3m over m plus 3. Good? And then from here, factor everything completely before canceling and finishing the problem off. So this is m plus 3, m minus 3, 9m squared, 3m, and m plus 3. So m plus 3 cancels, 3m cancels with 9m squared, and now that's only a 3m. And then we have m minus 3 divided by 3m. Okay, so here's the big takeaway. This method is only more helpful when you don't have addition and denominator, addition in the numerator or denominator, addition or subtraction. You see how here we had multiple terms being subtracted, multiple terms being added. That made me do this whole extra step here of getting a common denominator before I could proceed with the division. So for this particular problem, I would like method 1 better. But if you only have one fraction in the top and one fraction in the bottom, method 2 is nicer. Again, both will always work, but we're looking to be efficient, right? Work smarter, not harder. I have a few more examples. We're going to say use either method, but we'll talk about which one's better, okay? So boom, as soon as I look here and I see, oh, there's addition, there's subtraction, I'm going for method 1. I'm not going to play games. So here we go. First, let's factor all of the minor denominators completely so we could identify the LCD. So this is 1 over x plus 4 times x minus 1 plus 3 over x minus 1. Then we have 4 over x plus 4 minus 5 over x plus 4 times x minus 1. So I have 4 minor denominators. 1, 2, 3, 4. So the LCD is going to be x plus 4 times x minus 1. Good, good, good. Now, you could put that those are over 1 if you like. And just for the sake of not letting it get too messy, I'm just going to distribute and cancel and not write it all out. So you guys can handle it. Here we go. For this first term, x plus 4, x minus 1 cancels completely. So all I'm left with is a 1. Plus, over here, x minus 1 will cancel. So I have 3 times x plus 4. Over. Down here, x plus 4 will cancel. So I have 4 times x minus 1 minus, very good, just 5. Perfect. Already it looks so much less harmful, huh? Less intimidating. Then just distribute. So 1 plus 3x plus 12 over 4x minus 4 minus 5. And then this is 3x plus 13 over 4x minus 9. Nothing factors, nothing cancels, so we're done. See, it wasn't too bad. They look super intimidating in the beginning, but if you know what to do, you'll be fine. Okay, a couple more that you will encounter in your calculus class. Complex rational expressions may also appear in a slightly disguised form. How dare they put a disguise on? Through the use of a negative exponents. In this case, we must first carefully rewrite the expressions using positive exponents and then proceed as before. Caution, I want to make this very clear. If you have AB to the negative first, that's A over B only. If you have AB to the negative first, that's 1 over all of it, AB. Do you see the difference? So the exponent only applies to what term it's directly touching. Unless it's all in parentheses, then it applies to everything. So just pay attention. All right, example A, simplify. So first I'm going to rewrite this as 1 over A plus 1 over B. And then we have A squared minus B squared over AB. Perfect. So here's my minor denominators. Since I see addition here, I'm going for method 1 again. I sure am. I'm multiplying everybody by AB. AB. Okay. So when I distribute in the numerator, I'm going to have B plus A over, this is just going to cancel completely, A squared minus B squared. Are we done? Certainly not. We can factor that denominator. It factors into A plus B times A minus B. Well, B plus A is the same thing as A plus B, so now that's gone. So remember, when the whole numerator cancels out like that, you still have a 1 left over. 1 over A minus B. Beautiful. Okay, one more like this, and then we'll get into the calculus problems, okay? A times A plus 2 to the negative first minus 3 times A minus 3 to the negative first over A times A plus 2 to the negative first minus A minus 3 to the negative first. So again, first things first, rewrite the negative exponents as fractions with positive exponents. So we're still going to have A in the numerator, A plus 2 goes in the denominator. Minus 3 over A minus 3, okay? A over A plus 2 minus 1 over A minus 3. Are we okay? All right. Now, what's the LCD for all the minor denominators? 1, 2, 3, 4. It's just A plus 2 and A minus 3, yes? So we multiply by that in the numerator and the denominator. And then you distribute. Here, 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 and here. So let's see, we're going to have up top, A plus 2 cancels, so it's A times A minus 3. Minus 3 times A plus 2. In the bottom, we have A times A minus 3 minus 1 times A plus 2. Now, at this step, a lot of my students get too excited about the cancel party, and they want to do some illegal nonsense like canceling that or canceling these. You can't cancel when there's still subtraction or addition going on in the numerators. You can only cancel when everything's completely factored, you know, and there's no addition or subtraction. Then you can start canceling. But as soon as there's plus something, it's not time to throw your cancel party, okay? I'm sorry. So what do? We can't throw our cancel party. You just distribute and clean up, and then you see, oh, maybe I can factor and cancel. So this is A squared minus 3A minus 3A minus 6, A squared minus 3A minus A minus 2, yes? So that's A squared minus 6A minus 6. That doesn't factor. All right, we'll just leave it. And then this is A squared minus 4A minus 2. That doesn't factor either, so we're just leaving it. And that's the final answer, okay? Good. A lot of reminders maybe that you haven't used in a while, but don't feel badly. Math's one of those things. If you don't practice it regularly, you're not going to remember all the rules. So now let's see, in calculus, where does this sort of thing come up? We're simplifying complex rational expressions all the time. I'm starting in the beginning of the semester when you're looking at limits. Evaluate the following limit. And the first thing you always should do is just try to use direct substitution, namely plug in 3 for x. But if you do that, you get 0 in the numerator, 0 in the denominator, which is an indeterminate form. So we have to rewrite, play around with the expression so we can find the limit. And in this case, I'm like, ooh, it's a complex rational expression. Maybe we should simplify. Not maybe, we should. So what's the LCD for all the minor denominators? There's only 2, x and 3. So the LCD is 3x. 3x. If you want to put over 1, do it. Now let me distribute that through. So this is the limit as x approaches 3. In the numerator now, look, we're going to have 3x over x is just going to give me 3. Minus 3x over 3 is just x. And you guys don't distribute the denominator. You might be like, but Professor V, we've been distributing it the whole time. I know, but this is not, this doesn't have a denominator that I need to cancel, so just leave it factored. When you're doing calculus, most of the time you actually want your denominator factored. You'll see why right now. Are you ready? 3 minus x and x minus 3 can cancel, but I'm left with a -1. As a note, in case you forgot, a minus b equals negative b minus a. If you don't believe me, it's okay. Just distribute that negative on the right-hand side. That's negative b plus a. Isn't that the same as a minus b? If you think about it with numbers, it makes perfect sense. 5 minus 2, positive 3. 2 minus 5, negative 3. When you switch the order of subtraction, the sign changes. Well, why am I making note of that? Well, look, if you have a minus b equals negative b minus a, and I divide both sides by b minus a, then this cancels, and then I have, that's right, -1 equals a minus b over b minus a. So that means, you don't have to show all of this all the time, but when you notice, oh, here's 3 minus x, x minus 3, I want to cancel them. It's just since it's subtraction and the order's reversed, I'm going to add a negative because that ratio is equal to -1. Okay, look at us so fancy. So this is the limit as x approaches 3 of -1 over 3x. And then now can I use direct substitution? Just plug in 3 for x? Yep, now we have -1/9, and that's our limit. Perfect. Good, good, good. Okay, now after you work with some limits, you're going to learn the limit definition of the derivative. If you haven't watched that video lecture, you don't know what I'm talking about, I'll link it in the description. But the purpose of this video is not to teach you calculus. I have a whole playlist that does just that. This is to help refine your algebra skills and show you context in your calculus class where you're going to need these. So find the derivative of the function using the limit definition. So I'm not going to use the quotient rule, if you know what that is, of the derivative. So in order to find the derivative, I'm going to compute the limit as h approaches 0 of f of x plus h minus f of x over h. All right, so here we go. This is going to be the limit as h approaches 0. This is always the tricky part for students. F of x plus h. Everywhere you see an x, you're going to write x plus h. So this would be 1 minus x plus h over 2 plus x plus h. So that's f of x plus h. Minus f of x, that's 1 over x, over 2 plus x, all over h. Again, in order to evaluate this limit, since it's a complex rational expression, I have to simplify it. So the LCD of the minor denominators, of which there are only 2, is 2 plus x plus h and 2 plus x. So multiply by that top and bottom. The good news is this is a little more messy than some of the examples we started with. You only need to distribute in the numerator. Leave the denominator factored. That's true like 99% of the time in your calculus career, okay? So this is going to be the limit as h approaches 0. 2 plus x plus h is going to cancel with that one. So I just have this term from up top, which is 1 minus x minus h times 2 plus x minus, and then we have 1 minus x times 2 plus x plus h because the 2 plus x canceled. And then h, 2 plus x plus h, 2 plus x. Are we good? So yes, now we have to just multiply out everything in the numerator. It looks a little nasty, but you'll survive. Believe me. It'll be done in less than a minute, and you'll be like, oh, that wasn't so bad. So here we're going to have 2 plus x minus 2x minus x squared minus 2h minus hx minus, let me put parentheses so I don't do too much at once in my head, 2 plus x plus h minus 2x minus x squared minus xh over everything in the denominator. Just keep rewriting it. And then just as a note, everything without h in the numerator should cancel when you're finding the derivative using the limit definition like this. So what do I mean by that? This 2 better cancel. Oh yeah, see? There's negative 2 because that negative distributes. This x, he doesn't have an h, he better cancel. He does. This negative 2x, yep, that's a positive 2x. That x squared cancels. Negative 2h, no, that's not going to cancel. Let me highlight it so I don't lose it. Negative hx, guess what? That has an h, but it still cancels with this guy. Anybody else left? Oh yeah, poor little, that's a negative h, okay? So we have here now limit h approaches 0, negative 2h, and then don't forget this is actually a negative h. So altogether we've got negative 3h upstairs. Oh, look at us. Over h times 2 plus x plus h times 2 plus x. So then at long last we can cancel out that h from the denominator. That h that's been there from the get-go. Your goal is to make that guy cancel. And then now we should be in a place where we can evaluate this limit. So it's the limit h approaches 0, negative 3 over 2 plus x plus h times 2 plus x. Now we're taking the limit as h goes to 0, so I'm going to substitute in 0 for h. I don't have to write lim anymore. So we have 2 plus x plus 0 times 2 plus x. And I just have 2 plus x quantity squared in the denominator. Negative 3 over 2 plus x squared. Perfect. So if I were you, I would finalize my answer. Yep, it was f of x. And just say f prime of x, the derivative, is negative 3 over 2 plus x squared. Now, like I said, later on, you're going to learn the quotient rule. And that's a different way, faster way, that you can find the derivative. And again, you'll have to simplify complex rational expressions at times. So I'll make a part 2 video where we look at how to do that. But right now, this is just for when you're in the beginning of your calculus course. Okay, let's try another one like this. In fact, I want you guys to pause the video, try it on your own. So again, find the derivative using the limit definition. Okay, did you do it? I hope you did. We need the limit as h approaches 0, f of x plus h minus f of x over h. So this is the limit as h approaches 0. F of x plus h is going to be 1 over x plus h squared minus 4 minus f of x is just original function, x squared minus 4, and then this is over h. Again, we got to multiply by the LCD, which is just x plus h squared minus 4 and x squared minus 4. X plus h squared, lots of parentheses, so be careful. And then x squared minus 4. Good. This will distribute up top, okay? And then leave it in the bottom. So we're going to have x squared minus 4, because this will cancel with this, And then in the second term, x squared minus 4 cancels, and I'm just left with the other guy. So minus x plus h squared minus 4. Are you guys okay? Yeah. So here we go. H times x plus h squared minus 4, and then x squared minus 4. Leave the denominator as is. Don't touch it, but I do need to multiply this out and clean up the numerator. Remember, your goal is always to cancel out that h in the bottom. So this is limit, h goes to 0. If you need help practicing finding the derivative using the limit definition, I have a whole video dedicated to that, so it's in the description. X plus h squared is x squared plus 2xh plus h squared, okay? And then now hopefully we can just cancel out stuff in the numerator, right? You don't have an h, goodbye. You don't have an h, goodbye. Perfect. I'm going to factor the h out of everybody who's left in the numerator. So I can take out negative h, and then we have 2x minus h left, right? No, plus, excuse me. If I take out negative h, then I have, 2x plus h over h times x plus h squared minus 4 times x squared minus 4. Perfect. You guys, the worst is over. Look at us. We're surviving. Now I'm just going to substitute in 0 for h, so I don't have to write lim anymore. This is 2x plus 0 over x plus 0 squared, so that's x squared minus 4, and then another x squared minus 4. Oh, I forgot the negative. Shame on me. Negative. Okay. And then that's x squared minus 4 twice in the denominator, so I could write this as negative 2x over x squared minus 4 squared. Good? So then we can say f prime of x is negative 2x over x squared minus 4 squared. Beautiful. Okay, I have one last application. One other scenario where early in the semester in calculus, you're going to have to simplify a complex rational expression. It says, find the slope of the tangent line to the curve at the indicated point. So the function f of x is 8 over 4 plus x, and we want the slope of the tangent line to the curve at x equals 7. So the slope of the tangent line is equal to the derivative at this point. So first I need to find f prime of x, and then substitute in 7 for x. You could use a different definition for the derivative and find f prime of 7 right away, but I'd rather just do the more general version so we practice it, okay? And then sometimes they might say, oh, first at x equals 7, then they switch it up to x equals 0, then, you know, and so I wouldn't jump straight to this, and you're going to have to redo everything, okay? So here we go. Difference quotient time. Limit as h approaches 0. F of x plus h is going to be 8 over 4 plus x plus h minus f of x is 8 over 4 plus x over h. And then again, see how this is a complex rational expression? LCD is 4 plus x plus h and 4 plus x. Same thing here. Okay. Limit, h goes to 0. Once they start getting repetitive, it's good. Be like, oh, that means I'm getting the hang of it. 8 times 4 plus x minus 8 times 4 plus x plus h over h times 4 plus x plus h times 4 plus x. How are we doing? No, it's not time to cancel. It would be illegal. There is subtraction, remember? So don't throw that cancel party. Distribute the numerator. Should you distribute the denominator? No. Don't distribute the denominator. Okay, this is going to be 32 plus 8x minus 32 minus 8x minus 8h over h times 4 plus x plus h times 4 plus x. Okay, So let's see now, 32 cancels. We expected it to, it had no h. So does the 8x. Very good. So then we have the limit as h approaches 0 of negative 8h over h times 4 plus x plus h times 4 plus x. And then, yep, that h is gone. Now I can substitute in 0 for h. And we have negative 8 over 4 plus x plus 0 times 4 plus x. So this is going to be negative 8 over 4 plus x quantity squared. Okay, so then that tells me f prime of x is negative 8 over 4 plus x squared. So f prime of 7, because remember that's where they wanted the slope of the tangent line when x is 7, would be negative 8 over 4 plus 7 squared, which is negative 8 over 121. Boom. Now, just for extra practice, I think you guys should try. If you wanted f prime of 7 straight away, that would be the limit as x approaches 7 of f of x minus f of 7 over x minus 7. You guys should try that. You'll get the same result. The only problem is you won't have an expression for f prime of x. You'll just end up with the slope. So that's why I was saying if they changed where x was on you, you would have to go through the whole process again, which is why generally speaking, I do it the other way. Okay, so that concludes the lesson. Hope it was helpful for you guys, especially the ones who are jumping back into calculus right now, and maybe you've had a little bit of break. So this video lecture series is just for you, and I'll be working through reviewing algebra topics as it correlates with the entire calculus curriculum this semester. So don't forget to give the video a thumbs up, subscribe if you haven't already, follow me on Instagram, TikTok, Math with Professor V. I'll be back sooner than later. Bye guys.